Okay, these are going to be the notes for Chapter 6, Section 1. Okay, these are going to be really short notes because you actually did most of the information for this section yesterday in your flip chart. We will be adding some stuff to our flip chart today though. Or no, we won't, I'm sorry. Tomorrow we'll be adding some stuff to our flip chart. Okay? So now you know all of the definitions of the quadrilaterals, and you're going to see how you can apply those to problems that you'll see in your book. I think I'm going to do this in a little bit different order than the book did. Let's start with this example. Okay. Alright, the definitions in the book give you quite a bit of information about the shape. It tells you what things are congruent, and it tells you what things have 90-degree angles. So that's a lot of information to be used. Okay, so here's a picture and you're being asked to solve for the variables. And the only thing that you're told is that it's a rhombus. But because you know the definitions now, you know that a rhombus means that all four sides are equal. Okay, so in a sense we could pick any two sides we want and set them equal. But if you look, there's two different variables going on. So you need to look if you're going to set 5a plus 4 equal to something. Now remember, we said that all four of these are equal, so it really wouldn't matter which ones you set it equal to. But which one do you think would be your best option? I would pick this one because it's the only one that also has an a in it. So 3a plus 8. We know that these are equal because it's a rhombus. Rhombus means that all four sides are equal. So then you're just going to do the math to solve. Again, you could always solve this on the calculator, but I'm going to show you the math because it's important to review the algebra. Okay. Now we also need to solve for b. Wouldn't it make sense if these two are equal, then these two are also equal? So I can set these two equal because again it's a rhombus. All four sides are equal, so it doesn't matter which two I set equal in this case. Now guys, those of you that love to, and it's a good practice to go back and look at examples when you're working problems in the book, but keep in mind, geometry is different from algebra. You can't just follow an example blindly because every problem has something that's just a little bit different about it. Okay? If I change this word from a rhombus to something else, that could change the whole problem. So I know a lot of you really like to hold tight to those examples and try to do them exactly the way it's done, and then you get frustrated when you get it wrong, and it's because you're not paying attention to the small differences that your problem has. That's what makes geometry harder than algebra is every single problem is just a little bit different, so you have to really pay attention to why we're doing what we're doing and when to use it. Okay? Alright, so in this case we get a equals 2 and b equals 4. Okay? Now, another thing that we really want to focus on is always tying what we're learning back to algebra and back to the coordinate grid. So, another example I could give you is If I give you those 4 points and ask you to classify it, well, in order to classify this shape, you would need to know some things about its sides. You would need to know whether or not it had parallel sides, whether or not there was perpendicular sides, because perpendicular sides makes 90-degree angles, right? You would need to know if it had any congruent sides. We have given you formulas throughout this year that give you the tools to answer all of those questions. I'm going to have to look at that text or my phone's going to keep beeping. Okay. There are the 4 sides of my quadrilateral. Now, one thing you're going to be very tempted to do is to just look at it and say, well, it looks like a parallelogram, and that's what you're going to write on your paper. Or it looks like a trapezoid. Are we ever allowed to do that in geometry? And the answer is no. Alright, you have to verify. Okay, so there's our shape. So to me it looks like a square, but I don't know that it's a square. I don't know that these sides are all equal. I don't know that those are exactly 90-degree angles. Okay, so I need to check. How do you check length on a coordinate grid? Another word for length that starts with D is distance, right? So, step 1, distance. Okay, in order to check to see if it's a square, if you look back at your chart, let me pull it out. If you look back at your chart, a square is a rhombus and a rectangle. So that means all 4 sides must be congruent. The only way to check if they're congruent is to check all of their distances. Now this does require a little bit of work. It's a little bit tedious, but it's not hard. Okay, so if I'm going to do A, B, then I'm going to do the square root of, and if you need to look up the distance formula, go look it up. That's fine. Most of you I know have it memorized by now. So we would do 2 minus a negative 3 squared plus 4 minus 3 squared. And you would just type that in your calculator. Now y'all are lucky, y'all have the newer calculators, so it's a little bit easier to type that in these days. Okay, I'm actually using the old one right now because I didn't bring my new one home. 4 minus 3 squared. Okay, and I get 5.099. Alright, now I got 3 more sides to check. BC. Minus 2 squared, negative 1 minus 4 squared, squared plus negative 1 minus 4 squared, and I get 5.099. Now I need to do CD. 3 minus a negative 2 squared, and negative 1 minus a negative 2 squared. 5.099. And last one. -2 minus a -3 squared plus -2 minus 3 squared. And again, I get 5.099. So we have algebraically verified that all four sides are congruent. Again, we can't just look at it and tell. Okay, our eyes are not that accurate, I promise. Alright, step 2. So now we know that it's a rhombus, but we don't know if it's a square. We need to check the slopes. We need to see if we have perpendicular lines here. Okay, so check the slopes of all four sides. So AB is 4 minus 3 over 2 minus a -3. That's going to be 1 over 5. Slope of BC. Again, if you need to look up these formulas, go ahead, I don't mind. 4 minus a -1 and 2 minus 3. That's going to be -5 over 1, which is just -5. So we do have some perpendicular lines going, so that's a good sign that it is a square. CD, -1 minus a -2, 3 minus a -2. It's going to be -1 on top and a 5 on bottom. Wait, uh-oh. No, I'm sorry, that's a +1 on top. So again, we have 1/5, and looks like we're in good shape, but let's check the last one just to be sure. AD, not AB. So 3 minus a -2, and -3 minus a -2. That becomes a positive, so we get 5. That becomes a positive, so we get -1. So again, we get -5. And because these are both negative reciprocals, we know that we have 90-degree angles, which makes it a square. Okay, now not all of the problems will be this much work. Okay, if you're trying to determine if it's a trapezoid, then you would obviously only need to do slope twice. And trapezoids, we don't care about length. So the square is probably the most lengthy problem you would have to do. But this is the process for classifying it. See what it looks like at first, and you can kind of base what you do off of that, and then just do the verification afterwards. So again, the square, you won't have to do all of this work unless it's a square, because it's the most detailed definition. But that's the basic idea of it. Alright, one more example, and it's going to be more like example number 1. That's really your only two types of problems, is setting equations equal or setting them equal to 90 if they're angles, stuff like that, or the coordinate grid stuff. But let me give you one like your first example that's just a little bit harder, just to show you what kind of stuff the book can throw at you and what kind of stuff you might see on some tests someday. Okay. Okay, if this is a kite and we want to solve for x and y. Now, a lot of you probably have this down by now. Those two are equal, so we're going to set them equal. Okay, which is fine. But what if you had started with these two? These two are also equal. Would you be able to solve this equation? The answer is no. Okay. And that will come up on some of your problems. If you set two things equal, you're not always going to be able to solve it. Sometimes you have to solve a different equation first. So in this case, we're going to solve this one first. We get -1 equals 3 plus x minus 2x. That's a 1x minus 2x is a negative x. Then we're going to subtract the 3. You get negative 4 equals negative x. Anytime you have a negative x, just switch the sign of both of them, and you get x equals 4. Now you can take this and plug it in here. And we get y equals negative 25. Okay. And I just picked these numbers randomly. This is actually not a reasonable answer, because if you put negative 25 in here, you get negative 20, and length can't be negative, but that's just because I just picked random equations, and I wasn't sure if they'd work realistically or not. I was just worried about showing you the math. Okay.